The same side interior angles of a trapezoid are supplementary. The same side interior angles of a trapezoid are supplementary. That means that this angle and this angle, let's give them numbers. Hopefully those letters are easier to read in your packet, but I can't read them very well, so I'm going to refer to them as angles 1, 2, 3, and 4. Because this side is parallel to this side, these side pieces, these legs, are transversals, and therefore these are same side interior angles, and we know they're supplementary. So it means that angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. The isosceles trapezoid angles theorem. Remember, in an isosceles trapezoid, the legs are congruent. It's a little bit different than a regular trapezoid. We have an isosceles trapezoid. And in an isosceles trapezoid, each pair of base angles are congruent. Each pair of base angles are congruent. That means that angle P is congruent to angle A, and angle T is congruent to angle R. Angle P is congruent to angle A, and angle T is congruent to angle R. The diagonals of an isosceles trapezoid are congruent. So if you want to write out diagonals of an isosceles triangle, or isosceles trapezoid, diagonals of an isosceles trapezoid are congruent. We're going to try and make our notes as short as possible. That means that the diagonals going from PR and T to A, so PR is congruent to AT. So diagonals of an isosceles trapezoid are congruent. We're kind of buzzing through topic 6, just kind of being familiar with it. If you would like to challenge yourself by doing some of the extra pieces on your own, you may certainly do so. We are going to skip over the example 3 part and just talk about the triads together. Find the missing angles of the isosceles trapezoid. We're given that R is 135. That means that Q has to be 135. And then to find the other angles, 180 minus 135 is 45. And that means angle P is 45 degrees and angle S is 45 degrees. Given the ST is parallel to RU, what is the measure of TUR? So we're looking for this angle right here. So we're going to use this other side, and we're going to take note that together this is a straight angle. And so I can do 180 minus 47 equals 133. If this is 133, then we know that angle TUR is also 133. We're going to roll right into example 4. All horizontal beams of the high voltage transmission tower are parallel to the ground. The top section is an isosceles trapezoid. The center section is an isosceles trapezoid. If angle 1 is 138 degrees, what is the measure of angle 2? So if this is 138 and this is 138, to find angle 2, I need to do 180 minus 138, and that equals 42 degrees. So measure of angle 2 equals 42 degrees. Part B, we're looking at the same picture. It asks one cross support of the center tower is 4C plus 3. The other is 6C minus 5. Those are on that middle piece of the picture. Those are the diagonal pieces. And so remember that those pieces are congruent. So we would have 6C minus 5 equal to 4C plus 3. I will subtract 4C from both sides of the equation. That gives me 2C minus 5 equals 3. And adding 5 to both sides, 2C equals 8, and divide by 2, C equals 4. So we know that C equals 4, and so we need to go back to what was the question? What is the length of each cross support? So we actually need to take 4C plus 3, and we're going to plug in that C is 4, and that makes 16 plus 3, which is 19. Each cross support is 19 feet. We know that they were talking about feet because that was the unit measurement given in the original drawing. Go ahead and pause your video and do the try it, and then come back and check your answers. You should have taken note that diagonals are congruent, so 2a minus 1 equals a plus 13, and your work should come out to be a equals 14. Make sure you show all of the steps, just so you can check your answer. I gave it to you there. We are going to be skipping the mid-segment theorem of a trapezoid and concluding our 6-2 notes here. If you'd like to challenge yourself and have any questions on the rest of the parts that we skipped, please don't hesitate to reach out.